Hello AP Physics 1, it's Mr. Ng with Kinematics Practice Set 1, question number 5. So let's go through this question. A body moving in the positive x direction passes the origin in time at time 0. So it starts at 0 at time 0. Between time 0 and 1 second, the body has a constant speed of 24 meters per second. And at t1, the body is given a constant acceleration of 6 meters per second squared in the negative direction, so negative 6 meters a second. The position at 11 seconds is. Okay, so it looks like we got two systems. Let's start with system 1. Between t0 and t1, let's do VVATX, VVATX. So it looks like initial, final, delta. It looks like between 1 and 0 seconds, it's moving at a constant velocity of 24 meters per second. Right. There's no acceleration at this time, and the time displaces 1 second. All right, and we want to know how much space it displaces. So I think there's a very simple equation. The easiest equation for us is delta x is equal to velocity times t, right? So that means delta x is equal to 24 meters a second times 1 second. So delta x is 24 meters. Seems pretty easy. Let's do the next segment of this, right? So I just want to draw a neater line. So at the next segment, this is between T1 and T11. Let's do VVATX again. VVATX. The initial velocity is going to be 24 meters a second. We don't know the final velocity. It's going to decelerate at negative 6 meters a second per second. Meters second squared, but we don't know what this final velocity is going to be. We do know the time elapsed is going to be 10 seconds, right? And we need to know the final displacement. So the equation I would choose is delta x is equal to x initial plus initial velocity times t plus 1/2 at squared. Right? And no need to rearrange the equation because delta x is already in the beginning. So let's just fill in the blanks. Delta x is equal to our initial position, which is right here, right? At 1 second, it's at 24 meters. So we're going to put 24 here, plus our v initial, which is 24 meters again, 24 meters a second. This is just meters. Times t, this is going to be 10 seconds, plus 1/2 times negative 6 meters a second squared times 10 squared, 10 seconds squared. Okay, so let's see, this becomes 24, let's see, delta x is equal to 24 meters plus 240 meters plus 1/2 of negative 600 meters. So this becomes delta x is equal to 264 meters minus 300 meters. So delta x is equal to negative 36 meters. Okay, that's our answer, negative 36 meters. So the biggest things to kind of watch out for is number 1, just reading the question, figuring out what it wants. I divided it into 2 little segments. That makes it a little bit easier. And then some of us might have made mistakes with signs, so be very careful here, right? So this has a negative acceleration, so it does mess with that. Hey, thank you very much for watching.